Good morning, friends. It is Friday, April the 10th. It is Good Friday. It is Easter weekend, if you celebrate Easter. So we have a lot to be thankful for. A couple of housekeeping issues. I say issues, they're just things I need to tell you. Several of you did not complete the quiz on Monday, and Tuesday was due by Tuesday. Know that if you got your email, you should have got an email from Dr. Hannaford concerning grades and how that will work. If you want the option of a P, you have to be passing this class at the end of the semester. Okay, so the way that will work is I will input your letter grade as normal. All grading will go just as normal. I will input your letter grade, and then you have 1 week to decide, do I want to take a pass if you got an A, B, C, or D, or do I want to take the letter grade? Now, depending on what your major is, if you are a nursing major, a science major of any sort, a business major, or an education major of any sort, you should definitely reach out and contact your advisor to know whether you need to take the letter grade or the pass. Because if you intend, especially some of those are not taking the pass. So if you choose to take a pass, you will have to retake the course and get a letter grade for that. So make sure that you educate yourself, reach out to your advisor, and ask them what it will be appropriate for you to take. So be sure to do that. Let's see. We're still in chapter 4. We'll finish that up. I mean, we have very little left, so stay with me, and we're almost there. The hardest sections are probably coming up next week, so make sure you allot some time to this next week. So again, if you have questions, please reach out. I do not mind Zooming. I haven't heard from anyone in college algebra except 2 people, so I do encourage you to make sure that you are on board. Okay, section 3. When we want to talk about logarithmic functions today. Okay, and what logarithmic functions are, and for some of you, this may be the first time that you have seen a logarithmic function. Okay, so what they are is, number one, they're the inverse. Let me get all this up here. Logarithmic functions and exponential functions are inverses of each other. So if you remember in 4.1, we talked about inverses. We talked about how they undo each other. So what a logarithm does is it undoes an exponential, okay, or vice versa. A logarithm undoes an exponential undoes a logarithm. So that's going to be important for us today, because one of the main things we have to understand is how to convert back and forth between the two. So first of all, just kind of some things. If x is greater than 0, okay, so x is it has to be greater than 0. B is our base. B is base, and it is a positive constant, okay, because remember, B cannot be 1. So it's a positive constant, and it cannot be 1. Then you have this statement. Y equals log base b of x. That's how you say it. Y equals log base b of x if and only if b to the y is equal to x. And so what that means is I can go back and forth between these two forms. The first one is log form. The second one is exponential form. So you can kind of look at the arrow. The b, the x, and the y correspond between log form and exponential form. And that's what's going to be important for us, because that's how we're going to be able to convert back and forth between the two. Okay, so one note to think of, you cannot take a log of a negative number. And here's the reason for that. My x, when I'm taking the log, my x right here, x has to be greater than 0. You cannot take the log or the natural log as we look at it. Okay, log and natural log, and I'll explain what natural log is. Log or natural log of a negative number, and that'll come into play in the next couple of lessons next week. Okay, so we have 2 special cases for logs, and the first one is what's called the common log. And the common log is if you have y equals log of x. If there's no base sitting here, your base is just a little number. It's just off to the bottom. And so your base, okay, is, if there's no base sitting there, it's an understood base 10. Okay, if there's no base, it's an understood base 10. So anytime you just see the log of a number, it's an understood base 10. Natural log. So the second special case we have is y equals natural log of x, ln of x. And ln is our natural log function, and it's special because it converts to log base e. Okay, so if you have ln, what that means is log base e. Log base e. And so in the last section we talked about the natural exponential where you had e to the x and you it goes really fast, really quick. We saw that calculator button. So this is the special case for natural log. So if it's a log and it doesn't have a base, then it's understood base 10. If it's ln or natural log, that means it's log base e. Okay, so our two forms, and this is where we want to make sure we can convert between the two. We have log form and we have exponential form. Now, for log form, it does not matter whether you put the y on the left or the right. Okay, that part does not matter, and what you'll see me do is put it on the right more just because that's how I was taught. But so it does not matter which side the y goes on. And the thing to remember here is the b, the y, and the x all correspond. So if you identify the b, the y, and the x in one, you can change it to the other. So again, we're going to use this to convert back and forth. Okay, so the first set. Make sure everything's on here. Write each equation in its exponential form. So we want to go from log form. I wrote it up above. We want to go from log form to exponential form. So first you want to identify your y, your b, and your x, and then rewrite it as b to the y is equal to x. So 4 cubed is equal to 64. And then ask yourself, is that a true statement? What does 4 cubed mean? 4 times 4 times 4, 64. So yes, it's a true statement. Okay. The next one, again, identify your b, your y, and your x, and convert. Okay, and so I have a 3 raised to the negative 4 power is equal to 1 over 81. So remember that negative power flips over that fraction and becomes 1 over 3 to the 4th, and that's where the 81 comes on the bottom. So if you have a negative exponent, remember it's going to flip that fraction. So this is going from log form to exponential form. Okay, here's a natural log one. So if you're given y equals natural log of x, remember natural log is log base e. So to rewrite this, you have e to the y is equal to x. Okay, so let's go the other direction. So now we want to go from exponential form to log form. So again, you want to identify your b, your y, and your x, and then you want to correspond it to log base b of x equal to y. Okay, so our 3 cases here. The first one, okay, byx, so it becomes log base 5 of 125 is equal to 3. Okay, this one, it's log base 10 of 1 is equal to 0. And this converts, okay, because base 10 goes away because of the common log. So it can be rewritten as log 1 equal to 0. Okay, and then e to the first power is equal to 2.72. So that means log base e of 2.72 is equal to 1. And then remember, log base e is our natural log function, our natural logarithm. So we can convert log base e to natural log, and you want to make sure and do that anytime you can. The e goes away when you convert it to the natural log, remember. Okay, so we can also evaluate these by hand. Without using our calculators. We won't use our calculators until we get into section 4 and 5. Okay, so we're just evaluating these by hand, not using any calculator functions at this point. So first of all, to evaluate each logarithm, you want to set it equal to y, change to an exponential, and then solve it. And solve it by thinking about what that number to what power gets me the second one. So the first one, I've set it equal to y, change it to an exponential, so 3 to the y is equal to 81. How many times do I have to multiply 3 times itself to get 81? 4. Okay, the next one. 4 to the y is equal to 16. 4 to what power is 16? Okay, so 2. The next one, 1/2 to the y is equal to 1/8. Okay, 1 times itself is just going to be 1. 2 to what power gets me 8, and that's where the 3 comes into play. Okay, the next one, 3 to the y is equal to 1/27. And this one is special because you have your 3 in your numerator here, but you have your 27 in the denominator. So if you remember, that means it's going to have to, your solution is going to have to be negative. So that's why we have the -3 here. Okay, the next one, 3/2 to the y is equal to 8/27. So can 3 go to 8? No, but 3 can go to 27. So if it's going to the opposite position, your solution has to be negative. Okay, a couple of basic properties. Anytime you're taking a log and your base is the same as what you're taking the log of. Okay, anytime base is the same as what you're taking the log of. So an example, log base 5 of 5. Okay, it's going to be equal to 1. Anytime your base is the same as what you're taking the log of. Another example, if you have the natural log of e, remember natural log is log base e of e, so your base is the same as what you're taking the log of, so it's equivalent to 1. The next one is if you're taking the log of 1. If you're taking the log of 1, it's going to be 0 because base raised to the outside, so b to the 0 is always going to be 1. Okay, anything to the 0 power is equivalent to 1. So a couple of shortcuts there if you see those. Now we can also graph these, and the thing about graphing these is to graph, you want to convert to an exponential function using y for f of x, and then find points, so pick y values instead of x values, and then substitute in and solve. So change y, log base 3 of x, change it to an exponential, 3 to the y is equal to x, and pick y values and substitute in and get your x values. Now with logarithms, remember logarithms and exponentials are inverses of each other. So if you remember the graph from inverses, or remember the graph from exponentials, that graph was in quadrant number 1 and 2. So remember inverses are symmetric across y equals x, so it just flip-flops across that. So now it's going to be, your logarithmic graphs are going to be in quadrant 1 and 4. Our points are guaranteed points. With exponentials, we always got 0, 1, and 1b. So now with logs, we get 1, 0, and b1. Those are guaranteed points, and there are no y-intercepts. Does not cross the y-axis. Okay, the next one, y for f of x, change to an exponential, substitute in for y, and then graph. Okay, so a couple of things there. So just some housekeeping issues. So you have a quiz that is posted today that is due tomorrow, Saturday, April 11th by midnight. So hopefully you can get on that today. If it is showing that your WebAssign account is, your grace period is almost up, make sure you hit the yellow button on the left-hand side to start your trial over again. If that doesn't work, that's all I know how to troubleshoot it, so you'll need to call the customer service number under the announcements on Blackboard. Again, if you have questions, one thing to note in your WebAssign, so because you're going to be writing logs, it's going to be absolutely vital that you use the math toolbar on the right-hand side. So when you click into the solution, go to the right-hand side, and there'll be a toolbar there, and you want to look for your log and a base, and then input your answer. So please make sure you're using that, because it will count things wrong if it's not in the correct form. So be sure to use your math toolbar. If you have any questions, please reach out. And